Now, the first thing I want to talk about, I do not have a handout for. And that's because you don't really need to write a lot of this stuff down to understand what we're doing. I want to give y'all to have a good understanding of where some of this stuff is coming from. So if you want to take notes on this, you can, but a lot of this you don't really need to. Here. And I want us to relate what we're getting ready to do with what you did in college algebra and intermediate algebra. First of all, I want to talk about looking at the graph of a function. Remember that in order for something to be a function, it needs to have one output for every input. And the way that we could tell whether a graph is a function or not is we used the vertical line test. This is for function. So if I have this graph and I drew a vertical line anywhere on this graph, it is only going to hit my graph in one spot. So this is a function. It passes the vertical line test. If I have a sideways parabola and I were to draw a vertical line here, it hits my graph in more than one spot. So this is not a function. Once we looked at graphs and functions, then we also looked at inverses. And the way that we would look at a graph or an equation and figure out if it had an inverse, if it was 1-to-1. And what we did with our graph was look at the horizontal line test. So let's look at this same picture here. This is a function, but is it 1-to-1? No. If I drew a horizontal line, it touches my graph in more than one spot. So this is not 1-to-1. If I have this graph here, drew a horizontal line, it's only going to touch my graph in one spot. So this is 1-to-1. Now, if your graph is 1-to-1, then you can have an inverse. So I want to talk a little bit more about this in terms of just numbers. Let's look at these 2 points. Let's say that this is the point -3, 5, and I'm going to say this is the point 3, 5. And let's say that I started off with my y coordinate. I started off with 5. If I put 5 as an input into a function, I cannot get out just one number. So I can't find an inverse. If I want to figure out what number maps to 5, I actually have two answers that would get me there. -3 would get me to 5 and +3 would get me to 5. So this is a function, but I can't go backwards and have that backwards part being a function. So let me look at this function value this way. Right? If I've got some numbers here, I'm going to call them A, B, and C. I've got numbers over here. I'm saying 1, 2, 3. This number goes to 1. This number is going to map to 2. This number is going to go to 3. My inverse is going to take them back again. And this is my symbol for the inverse of a function. If I put a into my function, I get out 1. If I put b into my function, I get out 2. If I put 1 into the inverse, I get out a. If I put 2 into the inverse, I get out b. So you put one number in here, you get out one number. If you start here, put it into your inverse, you get out one number. That's what it means being 1 to 1. Right, one x value, one y value. So what we're going to do is relate what we're talking about here, or what we talked about here in college algebra, to our trig functions here. Now I've got this graph of sine x, and I'm also going to eventually look at the graph of y equals cosine and y equals tangent here. So if you want to sketch this out real quick, you can, but you don't really need to. If I were to look at this graph, I could see that it's a function. I could use my vertical line test. It's a function. But if I used my horizontal line test, I can see it does not pass my horizontal line test, right? It touches, horizontal line is going to touch my graph in a lot of spaces. This is a function, but it is not 1 to 1. So what mathematicians did in order to make some of their math work out nice is they restricted the function from negative pi over 2 to pi over 2. And now, since we've restricted this, now it's 1 to 1. On your handout that I gave you the other day, there was this part right down here. These are the inverses that we're talking about. So from negative pi over 2 to pi over 2 is this shaded part here, which means quadrant 1 and quadrant 4 is where I'm restricted. If I tried to put it, let me talk about this in terms of degrees for just a second. If I were to try to put in an angle in here that would give me, say, a 100-degree angle, that's not going to work. I don't have a 100-degree angle in this shaded part. So when we're working with inverse functions, we need to be sure that we're in the correct shaded part of our graph. Now, I've talked about our sine function before as being the sine of just any real number. It doesn't have to be angles anymore. It could be the sine of any real number, but it helps us to go back to this unit circle and think about angles again and being in quadrant 1 or quadrant 4 on my unit circle. Right. Now, one other thing I want to mention is that your domain of this inverse function here, it's not the same as the period of this function, because this has not gone enough to start repeating again for the period, right? It's just a small section that's going to encompass all of my y values. So I want to talk about the notation for an inverse sine function. I write sine, I put -1, and then I put x. This is not an exponent of -1. it is just the notation for inverse, just like I used this notation over here for an inverse of a function, like I did in college algebra. And I know that y'all didn't do that very much in college algebra. It was just that one lesson that sort of led into logarithms. Another way, I forgot my R, sorry, it's supposed to be RS. Let me write that again, inverse. Another way that you may see this is arc sine. Some books use arc sine instead of that notation. And they'll also use arc cosine, arc tangent as well. Do not get the inverse confused with a reciprocal. If I wrote sine x and then took all of that to the -1 power, this is an exponent that's going to mean 1 over sine x, and that is cosecant of x. So be sure that you understand the difference here. And also, if I have let me write this again, sine of that with that -1 being associated as the exponent of my x term, this means the sine of 1 over x. So that's a different meaning entirely. All right, so depending on where your parentheses is, where your -1 is, you're going to have 3 different meanings here. So be careful with that. Okay. This is actually the first problem I'm wanting to do here that I want you to be sure that you write down and you understand. Okay, so we're just going to look at the inverse sine 0.72. Now I can stick this into the calculator and get my answers. First of all, be sure what your directions are asking you for, whether you're looking at your angle in terms of degrees or radians. And in my problem here, I'm going to want to be using radians. So go to my calculator here, go to mode, be sure I'm in radians, and I am. If I want the inverse sine, I'm going to hit second sine, and notice I get that inverse notation, 0.72. And that's going to give me approximately 8.0. I'm sorry, 0.80. What you're doing here is you're saying sine of some angle theta is 0.72. What is that angle theta? Well, that angle theta is going to be 0.80. If I am looking at this on my graph of the restricted function, okay, up here, so this is my maximum, this is 1, this is my minimum. Down here, this is -1. I have 0.72 is on my y-axis. Let's say it's right about here, 0.72. And I want to know what x value is going to give me that y value of 0.72. Well, this x value would be 0.80. This is pi over 2. Now, if I were to try to look at a graph and figure out this answer, my graph would have to be very, very detailed in order for me to do that. And that's just really not feasible for any of the graphs that we're going to be doing in here. But what I can do is to use my unit circle to work with those special angles of like 30 degrees, 45 degrees, and 60 degrees, or any multiple of that. So anything that is like pi divided by 6 or pi divided by 4 or pi divided by 3, or multiples of those, are going to be on this unit circle. I gave you all this earlier in the week, or last week, I believe. So we're going to use this unit circle and this thing right here to help us figure out problems like this. Sine inverse of 1/2. On your test, you are not going to be allowed to use calculator to do this, because I want to be sure that you understand how this inverse function is going to be restricted in order for it to, or my original function is going to be restricted in order for it to have an inverse. So in order for it to be 1-to-1, we have defined our restricted values to this first and fourth quadrants. So we need to know how to do this without a calculator. So here are my steps. I'm going to just do this on a separate sheet of paper here so I can write a little bit bigger. Now to evaluate inverse trig functions. And if you want to put without a calculator, you can do that. All right, first step is going to be to determine the quadrant that I'm in. The second step is to determine the point on the unit circle. And then step 3, and this may seem kind of an odd step, but it's to name the angle correctly. Okay. Determine the quadrant, find the point on the unit circle, and then be sure we're naming the angle correctly. Those are my 3 steps. Okay. So step 1, figure out which quadrant I'm in. Okay. I'm in one of these 2 quadrants here. I'm either in 1 or I'm in 4. Now remember that when I'm dealing with my sine value, I am dealing with the y coordinate of the points that are on my unit circle, dealing with the y coordinates of the points. So am I going to be in quadrant 1 or am I going to be in quadrant 4? Where's my y value positive? 1. Okay. So I know that I need to be up here in quadrant 1. I've already said that 1/2 was dealing with my y coordinate. So if I'm looking for my y coordinate to be 1/2, it's this point right here. Right? So that's my second step, was to determine the point on the unit circle. Now, notice that there's a point over here that also has a y value of 1/2, but I'm restricted to these two quadrants. So the point that has the 1/2 is this angle here of pi/6. And that's an acute angle. That's pi/6. That's part of my, within my domain and range here. So this is pi/6 for my answer. My next problem, I'm going to have the inverse sine of negative square root of 3/2. So I need to figure out which quadrant I'm in. Remember that I'm restricted to these two quadrants. Sine is my y coordinate. So here my sine is negative, or my y value is negative. So I'm going to be down here in quadrant 4. So I need to find the point that has a y value of negative 3/2, negative square root of 3/2, which is this angle. It's very tempting to say that this angle is 5 pi/3. But that's not my answer. Let me do this because I don't want to mess up my units circle paper. This is 5 pi/3, but 5 pi/3 is not in my range here. Right? 5 pi/3 is when I start at my origin here, or x-axis, then I go around clockwise, and it would come back to that, right? I can't have pi/3. So what I want to do here is to start on this positive x-axis and go this way. So this angle is negative pi/3. Instead of going clockwise here, I'm sorry, going counterclockwise, I'm going clockwise. So I've figured out the point on my graph, but this last step here, to be sure I name that angle correctly, I cannot call it 5 pi/3. I need to be looking at this as negative pi/3. All right, so this value here is in between these two values here. Any questions so far? Okay, so cosine graph looks like this, and it's still a function that is not one-to-one. It is not going to pass my horizontal line test. So I need to restrict that function. And the way that's sort of a convention on our restriction here is we restrict our function from 0 to pi. You know, there's some things in math that are just like always true, like dealing with the distributive property, dealing with the commutative property. There's really nothing set in stone about why I need to restrict my graph to this. I could very easily have said, okay, I want to restrict my graph here, and that would have been fine. But convention has it that this is how we're going to do it. So you've got all of this information here because it's not necessarily one right way to restrict it. This is just sort of the conventional way that most people do it, and that's how our textbook does it. if I wanted to find inverse cosine of 1/3, then I'm looking at some point here on my y-axis or my vertical axis that's 1/3, and I want to figure out what angle measure is going to give me that value. And if you put this into your calculator, second inverse cosine of 1 divided by 3, you get approximately 1.23, 1.23 for your answer. So we are going to be doing the same thing with cosine as what we did with sine, but what about those special angles? What if I wanted to figure out the cosine inverse of negative square root of 3/2? Well, still following these same restrictions here, determine the quadrant that I'm in. Well, with cosine, I'm either in quadrant 1 or in quadrant 2. And remember that cosine is dealing with the x-coordinate of the points that are on your unit circle. So in this case here, I'm looking at my x-coordinate to be a negative number. And I know that if my x value is negative, I'm going to be in quadrant 2. So I look over here for my x value to be negative square root of 3/2. And I'm at the point 5π/6, or at the angle of 5π/6. And that's going to be my answer, 5π/6. All right, problem 3, I have inverse cosine of square root of 2/2. Again, I am dealing with either quadrant 1 or 2. And cosine is my x-coordinate. So if my x value is positive, in this case, this is a positive number here. So I know that I'm going to be in quadrant 1. So look over here in quadrant 1 and figure out which point has the x-coordinate square root of 2/2, and it's going to be π/4. So the cosine ones were pretty straightforward, right? Sine was where it sort of got to be a little more detailed, I guess you would say.